Okay, so here's some questions from the circle. This is a 2026 mock paper 2 question. Question 4 here is part A, part 1. The circle C has the equation x minus 3 to be squared plus y plus 5 to be squared is equal to 34. Find the centre and radius of C. So what we do here is we're going to write down our circle x minus 3 to be squared. We're going to write down plus y plus 5 to be squared is equal to 34. Underneath that, I'm going to write down from my log tables the equation of a circle is given as x minus h to be squared plus y minus k to be squared is equal to r squared. So let's work out the radius first. It's the easiest one. R squared is equal to 34. Take the square root of both sides and you will get r is equal to the square root of 34. So just let me mark in the different colour here, taking the square root of both sides. So taking the square root here will leave me with r, taking the square root of this side you're left with root 34. So there's our first part anyway, the radius, root 34. For the second part, so what we do is we match up. So I'm going to match up here now my minus h with my minus 3. So and this is the way I certainly recommend it. Minus h is equal to minus 3. And when you multiply by minus 1, you're going to get, and multiply by minus 1, you get h is equal to 3. And on the other side over here, again, matching up, we're going to get, so just get rid of these two. If it will delete for me, love it. And I'm going to match up minus k to the plus 5. So this is the whole point of me doing this here, minus k to the plus 5. When I multiply by minus 1, I get k is equal to, and multiply by minus 1, k is equal to minus 5. So a coordinate pairing always comes in the form hk, which gives us 3 minus 5. So there is your centre, 3 minus 5. And it's really important you do that, you match them up and then you multiply by minus 1. That will always give you the correct answer. If you try and read straight off it, it's easy to make a mistake. Part number 2. Prove that the point 2 minus 2 is inside the circle. So you've got three things here. You've got the left hand side less than the right hand side. Well, that means that it's inside. You've got the left hand side is equal to the right hand side. That means that it's on the circle. And if you prove that the left hand side is greater than the right hand side, that means that it's outside the circle. The point lies outside. So what do I mean by left hand sides and right hand sides? So if we go back to our equation of our circle there, we have x minus 3 to be squared plus y, I think it was plus 5 to be squared is equal to 34. So when I'm talking about left hand sides and right hand sides here, I'm talking about a left hand side here, I'm talking about a right hand side over here. So let's sub in our stuff. Let's set it up first of all. So instead of x, I'm going to leave it blank. Instead of y, I'm going to leave it blank. And I don't know what the story is here, so I'm going for question marks in the middle there. So our point here is x, y. So we're going to sub in 2 for x. So let's color code that so we can see it nice and clearly. If not, let me bring it up there that well. So 2 coming up here. Right, that's going in and for x. In for y, I'm going to put in here minus 2. So minus 2 here for y, that's going to go in there. And so now I just get my calculator and I work all this stuff out on the left hand side. That's 1, that's going to be 3 squared is 9. I think I get 10. And 10 is going to be less than 34. So I told you up above there, if the left hand side is less than the right hand side, it's inside. So that implies that the point 2 minus 2 is inside the circle. So the circle lies inside the circle. Part number B here, right? It gives us a circle. Q has equation with centre A and touches the x-axis at the point B, touches the y-axis at the point C. Write down the coordinates of A, B, and C. So A here, out 3, up 3, easy. B here is out 3, you don't move up x or y, so 0. And here you move nowhere for x and y, and you just step up 3. That's lovely. Then it says write down the equation of the circle Q. I suppose the equation, so you need, it depends on how you want to do this. There's a couple of different ways of finding the equation of the circle Q here. So we need to find the equation of the circle, we need the centre, which is point A here, and that's 3, 3. And we need the radius. Currently, we don't know the radius. We haven't been told it. But we can figure it out by looking at the diagram up here. Here's the centre. The radius is to any point on the circle. So from here to here, you have a distance of 3 units. Your radius is 3. Lovely jubbly. And we go down here then to our circle now. So our circle is going to be x minus h to be squared plus y minus k to be squared is equal to r squared. This fella here is h, this fella is k. So we set it up. We're going to get x minus blank to be squared plus y minus blank to be squared is equal to blank to be squared there for r. So h is 3, k is 3, and the radius is 3, and our last step is just to tidy that up. X minus 3 to be squared plus y minus 3 to be squared is equal to 9. Finito.